Welcome to the Chemistry Live channel. Today we are discuss about classification and structure activity relationship of antimalarial drug. So first we'll take a look about the classification. It's a chemical classification. In previous video we learned how therapeutical classification is useful. In that video we'll discuss about the chemical classification. So in the case of chemical classification we to divide into 8 sections. The first is 4-aminoquinoline. The second is 8-aminoquinoline. Both are called amino-quinoline analogues classification. The part of that one. The next is aminoacridine, Guanidine Analogues, Pyrimidine Analogues, Sulfone Analogues, Quinine Analogues, and at the last new antimalarial drugs. So now first take a look the classification and related drugs. So amino-quinoline analogues, aminoacridine analogues, guanidine analogues, pyrimidine analogues, sulfone analogues, quinine analogues, and the new antimalarial drug. And related to that, amino analogues more subdivided into the 4-amino and 8-aminoquinoline analogues. The next, the aminoacridine having quinacrine and aminoacridine drug, guanidine having a proguanilin hydrochloride and this kind of drug, pyrimidine analogues having pyrimethamine and trimethoprim drug. In a sulfone analogues there is only one, there is a dapsone. In quinine analogues there is a quinine sulfate, and new antimalarial drug having a artemisinin, lumefantrine and mefloquine. So the first analogues we'll take a look about 4-aminoquinoline. So in the 4-aminoquinoline analogues, see this is the structure of 4-aminoquinoline, and that derivative act as an antimalarial agent, treat to erythrocytic plasmodium infection which include amidoquine, chloroquine, hydroxychloroquine. It is also used as an antibacterial, anti-asthmatic, antifungal, anti-inflammatory, antiviral as well as antimalarial agents. So that kind of drug, the bunch list is here. The chloroquine phosphate as well as the hydroxychloroquines which is used in the treatment of COVID-19 in previous. In the next slide, we will take a look about 8-aminoquinoline analogous drug. So that 8-aminoquinoline analogous drug having a nitrogen at the 8th position, like if we start with here, first, second, third, fourth, fifth, sixth, 7 and 8 position. So that analogous agents are antimalarial agents to eradicate malarial hypozoontes from the liver and have been used for the malaria prophylaxis. It kills all stages of malaria parasite and they are particularly well suited for malaria elimination efforts. That is example of that kind of drug which is fallen under the category pamaquine, primaquine, pentaquine, isopentaquine and phenocides. So another analogues is aminoacridine analogues. In the aminoacridine analogues, there is basically one unit is 4-aminoquinoline and another unit is benzene ring. So we can take a look of that one, how it's useful. So 9-aminoacridine derivative has been found highly toxic compared to 4-aminoquinoline analogues. So its toxicity is too much high compared to the 4-aminoquinoline analogues. In addition to this, it is highly fluorescent dye used clinically as a topical antiseptic and experimentally as a mutagen. So clinically they are used as a topically antiseptic and experimentally used as a mutagens. An intercellular pH indicator and a negative mode small molecule matrix. So it's used as a negative mode small molecule matrix as well. The given drugs are fall under the category. One is quinacrine and aminoacridine. These two drugs is fall under the category of aminoacridine. The next class is guanidine analogues. In guanidine analogues, here we see there is NH2 group, NH double bond, NH group, NH, NH and NH group. The guanidine analogous drug having a NH group, here we see there is 1, 2, 3, 4, 5 NH group. That analogous agents are act as antimalarial only if it's cyclized metabolically to the dihydroestriazoline analogous having a close resemblance with pyrimethamine and petridine moiety of folic acid. Following is the drugs are fall under the category of guanidine analogues. This is proguanilin, cycloguanilin, chloroproguanilin and bromoguanil. In pyrimidine analogues, that kind of drug having pyrimidine ring Pyrimidine analogues are antimetabolites that interfere with nucleic acid synthesis. It behaves as hydrophilic molecule and requires specialized membrane transport from entry into the cell. An antimalarial drug, the mode of action of that kind of analogues are exoerythrocytic and erythrocytic form of P. falciparum together with exoerythrocytic form of P. vivax. That class of drug for the category is pyrimethamine and trimethoprime. We switch to the another class of drug, which is sulfones. Sulfones having itself unique properties because it having SO2 group at the bridge. Like a large number of diphenyl sulfone analogues have been developed for the treatment of leprosy. So we all are aware what is the leprosy because in previous video we discussed the leprosy. 4,4-diamino diphenyl sulfone dapsone is a member of this class, incidentally shows potentially prophylactic activity against resist P. falciparum. The combination of dapsone and pyrimethamine has been effectively used in the treatment of malaria due to chloroquine resistance falciparum. If the Plasmodium falciparum is resistant with the chloroquine, then we can use dapsone plus pyrimethamine combination. So that is only one drug falling in the class of that one is the dapsone. In the next class, we will switch the quinine analogues. So quinine, we are well aware that is quinine group. That quinine group is obtained from the bark of cinchona trees. It is alkaloids. It affects the erythrocytic form of Plasmodium. It's widely used for the suppression and control of the malaria caused by P. vivax, P. malaria and P. oval, but it is less effective against the P. falciparum. So it's rarely used. Now expect chloroquine resistance cases when its administration is followed by the combination of pyrimethamine and sulfadoxamine. There's only one drug for another category. Here we have list of one drug, it's quinine sulfate. In this kind of new antimalarial drug class, Plasmodium is resistant with another type of or all the type of the drugs, then we can use this kind of newly prepared antimalarial drug. So increasing the antimalarial drug resistance is a threatening effective antimalarial drug treatment. So malaria control and elimination. In vivax malaria, chloroquine resistance is an increasing problem. Artemisinin combination therapy have a combination artemether, lumefantrine and amodioquine. In addition to that, there is a DHA dihydroxyaminoquinoline, pipiraquine and mefloquine are currently studied effectivity or potency and the safety in the treatment of uncomplicated falciparum malaria in areas of artemisinin resistance drug. A fewer drug has been classified under that category: artemisinin, lumefantrine and mefloquine. That artemisinin combination therapy is in short we can say ACTS. Next we will discuss about the SAR relationship or structure activity relationship of antimalarial compound. So what is structure activity relationship first? I want to tell you something about that. The structure activity relationship is the relationship between the 3D models of the compound and its metabolic effect, or we can say the group which is available in the compound and the metabolic effect in the organ. So here we discuss about mainly three relationship: 4-aminoquinoline, 8-aminoquinoline and 9-aminoacridine. So in that context we have to switch to the first 4-aminoquinoline. So let's see what is the 4-aminoquinoline first. So as per previous, we will see the 4-aminoquinoline is a drug having an amino group at C4 position. So that is the C4 position and drug must be at that position at R1. So in the bracket we can write at R1 position. So if the drug is at R1 position, we can consider at C1 position. Now we will talk about the structure and the chemical groups are available at different kind of positions. So let's see first with 4-aminoquinoline. There is 4 type of drug is available in the class which we are going to study previously, the synthesis and all section. So chloroquine is nothing but at R1 position having 1, 2, 3, 4 and 5 carbon chain, include that NC2H5 group, and rest of the stuff is at R1, R2, H, R3, Cl, R4, R5, R6 having a CH. Another is hydroxychloroquine. The name itself suggests it has a hydroxy group at the side chain or R1 position. Here the whole stuff is same like a chloroquine, but only the addition of that OH group at the NC2H5 ring or the NC2H5 side chain. The rest of the functional R2, R3, R4, R5 and R6 remains same. In amodiaquine, there is a replacement of that C5 carbon chain with that phenolic unit, and that has difference in activity, but still we have NC2H5 twice ring with us. In xantoquine, we see The sontoquine and the chloroquine structures are just resemblance because R1 moieties are same with a branch chain. Here there is a branch carbon, here the branch carbon, but here this little bit condition is changed, is the R6 position. So here what we see, the R6 position has a CH. Let's see with the SAR relationship of the 4-aminoquinoline drugs. So there is a 4 kind of drugs. The first one is chloroquine, the second one is hydroxychloroquine, the third one is amodiaquine, and the last one is santoquine. So you can see here the drug having a different kind of R1 ring, but here in the santoquine, as we discussed, here the only CH3 group is changed compared to that chloroquine. Here chloroquine has H, amodiaquine has CH3. Itself it has some unique properties, so we can take a look on that one. Okay, so before the start that one, we have to take some little bit importance of that SAR. A consideration of SAR reveals that the tertiary amine is important for activity. Okay, so what we want to see, the tertiary amine group is responsible for the activity. We have 2 tertiary amine group in that 4-aminoquinoline analogous drugs. The first one, tertiary amine, is that in the ring is a pyrimidine ring or quinoline ring. And the second one is that NCH2 CH3 group. So we have a 2 tertiary amine group which is responsible for the activity in this. The side chain length and 7 chloro group are opting. So here the side chain length, the length is C5. We are opting the length. Okay, yes, we have a C5 chain length and the chloro at that position. So the both we have to set it down and then optimize it the condition to prepare a drug for a 4-aminoquinoline analogues as an antimalarial property. The substitution of hydroxy group on the other hand of the group on the tertiary amine generally reduce the toxicity and increase the plasma concentration. So if we have to use this or implant this OH group from that chloroquine to hydroxychloroquine, it reduces the toxicity. So it helps to reduce the toxicity. And increase the plasma concentration. Another, incorporation of the aromatic ring in the side chain as amodiaquine produce a compound, reduce the activity and toxicity. So what happened if we introduce that group, if we introduce that benzene group, or if we introduce the aromatic ring in place of that chain or branch chain, we reduce the activity as well as the toxicity. The introduction of second methoxy group at position 2 and 5 increase the therapeutic index. Even number of methylene group were found to be less active than consider the odd number. Terminal amino group may be having a primary, secondary and tertiary. If we have the amino group at the terminal position, it should be primary, secondary and tertiary. But if it is in the aromatic ring, then it should be or it must be have secondary amino. So next we will switch to the SAR relationship of 8-aminoquinoline. We will take a look of the first, what is 8-aminoquinoline, just little bit idea about that one. So the 8-aminoquinoline having amino group at C8 position. So what we'll see in here, the amino group, yes, we have amino group. In the previous 4-aminoquinoline, we have amino group at C4 position, and then here we have amino group at C8 position. So the numbering is the same. So here there is C8 position, and here we put all the amino group and the side chain. So in the next slide, we'll take a look about the structures with the table, with the list of that drug and the position. So here we have 5 types of drug available with us. The first one is primaquine, the second is pamaquine, the third is quinosides, fourth is pentaquine, and the last one is isopentaquine. Here the whole you can see R2 group having OCH, and the rest of R1, R3, R5, R6 have a hydrogen with it. But there is a change in the R4 position. R4 means carbon 8 position. So why we need to change its carbonate position? Because here the same, if you check out the carbon length 1, 2, 3, 4 and 5, here also 1, 2, 3, 4 and 5. Here there is something difference, 1, 2, 3, 4. Here 1, 2, 3, 4 and 5, and here 1, 2, 3, 4. So what we are conclude with the help of that chain, okay, if the number of the carbon chain is between C4 to C6, it is great for activity. Okay. So we will take a look about that. So what is the difference between the primaquine, pamaquine, pentaquine and isopentaquine? So here in the primaquine, we will see there is a C5 carbon chain with one branch at C1. And at the end we have a primary amine. In the pamaquine, the same structure, but the and amino group is not more a primary amine, it's a tertiary amine. If we take a look of the pentaquine, then we'll see here in pentaquine, there is a no branch chain in a pentaquine, C5 carbon without branch chain, and the end we have NH, CH, CH3, 2 group. In this isopentaquine, there is the same structure at the branch, but we have, or the same structure at side chain, but we have a branch at C1 position, and that helps to improve the activity. So here we see the carbon 1 there is a branch, and rest of that side chains are just as it is with the pentaquine. Another is quinosides. So in the quinosides we take a look that each and every primaquine, palmaquine and isopentaquine we have a branch at C1 position, but in the case of the quinoside we have a branch at C4 position. So that C4 position branch, it's also help to increase the activity. And here the amine group is tertiary amine as it is, but here the CH3, not C2H5. So now we will switch to the more deep in the structure activity relationship with following the structures. And then see, we have 5 kind of drug, so we have 5 kind of structures: primaquine, palmaquine, quinosides, pentaquine and isopentaquine. So what is the structure and what help that side chain to reduce the activity, to increase the activity, to take a well combined with plasmodium and then DNA structure and break it down and kill that plasmodium. Okay, so we have taken a little bit biochemistry on that. So what happened? You might be heard about the word which is called lock and key model. Okay, you heard about the word, I think, lock and key model. So what is lock and key model? Is for enzyme, I think. So the lock and key model is nothing but there is a proper enzyme for a proper lock. So if you have that enzyme, then it's lock inside, binding inside, and the reaction or the process. Or we can stop the growth of that virus and to kill that site. So what that did, what the primaquine and another 8-aminoquinoline, 4-aminoquinoline and 9-aminoacridine drugs did. See here, if we build a pocket cavity or key role is like that here. If we're trying to do with this one, so you can see here the size is changed, so pocket cavity is little bit changed. In that case as well, the pocket cavity is changed because the size is changed. Here you can see the pocket cavity is changed, but not more. But both cases are pocket cavity is different. If here we take a look, the pocket cavity is also little bit different. So what is that? When the plasmodium comes to contact with our blood cell and just try to put it in a blood cell, then what happens? Then they are start that multifunctional property, or they start that process. They are division, and they one from they become 2, 3, 4 and so on, and that increase the concentration, the plasmodium concentration in the blood level. So our aim to stop that plasmodium, increase the increment in the plasmodium concentration. So what we did, we are using this drug which prepare a cavity and which block the agent or with the enzyme who help to just increase the concentration of plasmodium in the blood cell. So we will take a look which functional group is acting a key role or act as a key role to stop that one. See, we will start with that one, 8-aminoquinoline analogues. Drug contain quinoline ring having an antimalarial property. Yeah, the property increase after the addition of side chain at amino group to the quinoline ring. Okay, so what I mean to say, the side chain itself has no property, but when you are introduced a side chain in the quinoline ring, it gives a property. The OH3 is not necessary for the antimalarial activity, but when it's replaced with the OC2H5, shows the less activity and higher toxicity. So if here we add OC2H5, suppose we have a OCH3, if we take a look like that, okay, and if we add OC2H5, then the situation is something like that. So here if you create a cavity, then the cavity should be like that, and here it's something. So that helps to improve the activity, but that can't. Okay, so less activity. It reduces the activity as an antimalarial drug, so we cannot optim or we cannot prefer this OC2H5 group in our compounds. When the OCH3 group replaced with CH3 compound, it's become inactive. Okay, so what happened? Like direct is connected with oxygen and we just switch to the direct methyl group, so the cavity is completely collapsed here. There is no cavity due to the oxygen atom in that CH3 group. So it's become inactive. So the CH3 is also not favorable to replaced with the OCH. When we introduce halogen atom, increase the toxicity and drug become less potent as antimalarial drug. So in 8 amino quinoline group, if we introduce halogen atom, it not help to increase the activity, but in oppose it will decrease the activity and drug become. A pamaquine having a tertiary amino group, here we see here the tertiary amino group, where it's converted into the primary amino group is called primaquine, which is less toxic and well tolerated drug in the class. So primaquine is less toxic, so that one is less toxic and well tolerated drug in the class. In the next slide, we will take a more look about the same drug and a little bit more points with us. The quinoline ring is necessary here what I mean to say, the quinoline ring is necessary for the antimalarial activity. When the pyrimidine ring is converted into the piperidine ring, a compound turns to be inactive. So what is pyrimidine ring, what is piperidine? Here there is the ring, pyrimidine ring, and when it's converted into piperidine ring somehow like that, so it will be inactive. Okay, so compound become inactive because that key role is that lone pair of the electron which is present here and the electronegative inside the benzene ring, because it's surplus and is trying to help to increase the activity. As we can add the chloro group over there, that is also reduce the activity, because the chloro group always pull the electron from the benzene ring, and when it's pulled the electron from the benzene ring becomes a little bit electric, and so that lone pair take a part in the benzene ring and start to take a part in the benzene ring, and itself the pyridine ring is no more, it's become piperidine ring. So what we have to do, we have not used piperidine ring. The next point is a pentaside or the pentyl side chain at C8 explore the maximum activity as a potent antimalarial drug, but slightly modification to that side lead to the reduction the potency as well as antimalarial. So if we change here the carbon position, okay, or we increase the carbon position at the side chain, so it increase and decrease the activity. Chain leads to be reduction in the potency, so it should be potency is become a less in the chain side and the drug is less potent, become a less. When the branch chain is converted into the straight chain, the drug called pentaquine having a less efficiency compared to pamaquine and primaquine. So pentaquine has a less efficiency. So what we are conclude from that step, yes, our side chain must has branch. So if we have a branch chain, then increase the activity. If you have a not branch chain, then it decrease the activity. If the terminal N having more and more groups to attach with at one longer group attached to that one, it will decrease the activity or will slightly decrease the activity. So compared to pamaquine, the primaquine has higher activity or the top in the class. So what is the conclusion from that point? We have to written it down. The conclusion is the 6-methoxy group or the 6-position methoxy group and 4-6 carbon side chain. In addition to that, branch chain and a not branching at the terminal nitro group or terminal amino group provide a best activity. So that is our conclusion for the 8-amino quinoline drug. So next we will talk about the 9-amino acridine drug. So what is the 9-amino acridine drug? In that here, there is a first part is 4-amino quinoline and the second part is benzene ring. So there is a fusion of these two. So here we see at C9 position we have amino group. So which is the C9 position? That is the C9 position. Here we put the amino group. The another use is it acts as a green fluorescent dye. It was used as antiseptic for a wound and infection. So first you have aware with what is the fluorescence. So the fluorescence is nothing, but when you excite the molecule, the electron goes from ground state to excited state, or we can say S1, S0, S1 and S2 state. Okay. If it directly come, it will come from, suppose this is S1, S2 and S0. If it's come first S0 and then come back to ground state, it got fluorescence by intersystem crossing. But when it's go to the another and it's come back to that one, then it's called phosphorence. So if they are green color, it's green fluorescence. So that is some funda of the fluorescence. If we can look it more deeper in the photochemistry portion. In the next, we will see the table having a different kind of drug and then R1, R2, R3, R5 component. Here we see quinacrine, only 3 major changes in R2, R3, R7 and that is R8 or 1 carbon. What is the change? Here we have NH2 and here we have N, that's the change. So we'll take a look first about that 4 drug: quinacrine, aminoacridine, acriquine and azac. Quinacrine, aminoacridine and azacrine have the same R1 but changes in R2 and RA. So what will help to change that? So in that quinacrine R2, R3, R2 has a H, R3 has a Cl, R7 has a OCH3 and R1, or we can say R8. But in aminoacridine, the H is replaced with the amino group, NH2 group, and in azacridine, the CH will replace with the help of the CH will replace 2N. In acriquine, there is no branch available at the position. The rest of the sum same as a quinac. So now we'll switch to the more deeper in SAR relationship in the 9-aminoacridine. We have at least 4 kind of compounds with us. So when a side chain 2-amino 5-diethylamino-pentane is introduced at C9 position, compound shows antimalarial property. So this group helps to show antimalarial property is confirmed by the previous 2, 4 and 6 as well, 4 and 8 aminoquinoline as well. When methoxy at C2 position and chlorine at C6 introduce antimalarial property. When methoxy group at C2 position, that is the C2 position, and chlorine at C6 position, it introduced the antimalarial property. But when a methoxy group shifted to C6 and chlorine shifted to C2, it's lost the antimalarial. And methoxy is replaced by ethoxy, toxicity increased. If we replace, then toxicity is increased. And if it rotates to another position, it's lose about 50% of activity because it changed the fold. It's changed the cavity to bind out with that amino acids or with some proper kind of enzymes to stop the activity of increase the number in plasmodium concentration. When chlorine is replaced with other halogen atom like F, Br and I, it's successive loss in the activity. So we can take a look as well here. If we are change the chlorine or if we replace the chlorine with another halogen FCl, FBRI, we have faced a lots of problem and lose the activity. The side chain 2-amino 5-diethylpentane itself has a no there's no antimalarial properties, but when we attach with the aromatic ring, it reveals the antimalarial behavior. So that is side chain. As previous we talk about, the side chain has no property, but when we introduce with that quinoline ring, then it shows its property because of the cyclization, because of that ring current, and because of that the lone pair and the effect of pyridine ring itself. Especially when nitrogen atom at C1 introduced, azacridine helps to increase the antimalarial property and rapid on. So what is that? So here again the lone pair, here we have a 2 lone pair and then NH2, so that provide a best stabilized conformation or configuration of that compound or 9-aminoacridine compound, which compound helps to increase the antimalarial property and which help a lot in that antimalarial drug synthesis and that for the cure system. It has rapid onset action. So rapid onset action means there is fast action compared to the other 9-aminoacridine derivatives. There is some more one point we have just remained, and the point is this 2 part, a German separates the quinacridine into the 2 parts. The yellow part is that one, it's chloroquine part which is active, and that part is inactive which is in pink color. There is reference if you wish to read further. And thank you for watching, guys. If you have any question, just write in comment section, and please subscribe the channel and press the bell icon to get a more notification. In our next video, we will see mode of action and the shower of mode of action, how mode of action is useful and what is the mode of action of the antimalarial drug.